This is Unit 2, Matter, Lesson 4, Properties and Changes of Matter. So how are the properties and changes of matter determined? The objectives of this video, I can identify the states of matter. I can differentiate between physical and chemical changes. I can determine the phase of a substance at STP using Table S, and I can construct particle diagrams for solids, liquids, and gases. So review due now. So states of matter, you should be familiar of these from previous science courses, but solids have a definite volume and a definite shape, and the particles vibrate. We're going to have a symbol of this parentheses S to represent those solid particles. And if I were to draw a particle diagram, I'm going to have them all nicely lined up in a fixed structure, close together, packed tight, mostly touching in a little cube or another shape. It would have any shape that you want, but you can tell it's a solid because they're packed together. It has a definite volume and a definite shape. Liquids have a definite volume, but they take the shape of the container. They're constantly moving, and you're going to use the symbol parentheses L. So that you're going to draw these a little bit together, but they're going to be kind of flowing around down at the bottom of my container. They're not going to fill it up. They're going to take whatever shape it's in. So they'll kind of move around each other and not be really set. Symbol AQ means water solution. So that means I have something dissolved in it. A gas has no definite volume and it fills the container, therefore no definite shape. They're compressible. I can stick them, I can press them together, and they have the greatest amount of movement. So if I were to have a gas, they're all over the place, just jumping all over. They'll take the shape of the container, fill it out, and they have no definite volume. We're going to represent them by the symbol G. So determining the phase of matter at STP. So at different temperatures, a substance can be in a different phase of matter. So I could have an element, for example, sodium, in a solid, a liquid, or a gas phase. Scientists determine the normal conditions of temperature and pressure, and they call this standard temperature and pressure, or STP. So determining the phase of matter at STP, standard temperature and pressure can be found in Table A. So you should not forget this. This stands for standard temperature and pressure, STP. And these are the standard pressure and the standard temperature. 101.3 kilopascals or 1 atmosphere. This is the same value. That is standard pressure. 273 Kelvin and 0 degrees Celsius. That is standard temperature. So using Table S to determine the phase of a matter at STP. When you look at Table S, you're going to see at the very top all these different labels. To determine the phase of matter at STP, we're going to look at our melting point and our boiling point. The way I like to look at this is if I have the temperature. If the temperature I'm looking at, in this case STP, the temperature of STP is 273 Kelvin. So at 273 Kelvin, what is the phase of matter of boron? So I'm going to look at boron. Here's boron right here. It's element atomic number 5. I'm going to look at its melting point. Is 273 below 2348? Yes, that value, 273, lies lower than this. Therefore, it's going to be solid. If I had a value that was between this, such as if I was looking for the state of matter of an element at STP and 273 fell between the melting point and the boiling point, that would be the liquid. However, for example, if I had hydrogen at STP, notice that the boiling point of hydrogen is 20. 273 is higher than that. Therefore, at STP, hydrogen would be a gas. So if you look at this description here, the melting point would be this line here. If my temperature is lower than the melting point, it has not melted yet. Therefore, it's a solid. This here would be my boiling point. If the temperature is higher than the melting point, it has melted already. If the temperature is lower than the boiling point, it has not yet boiled. Therefore, that would make it a liquid. If the temperature is higher than the boiling point, it has boiled already. That would make it a gas. So that's how we use table S to determine the phase of matter at STP. So for example, what phase of matter is H2O at 280 Kelvin? So 280 Kelvin is my temperature, or 7 degrees Celsius. So 280, is that greater than or less than or equal to 273? 280 is greater than 273, so it would fall in this range because 280 is also less than 373. Therefore, H2O will be a liquid at 280 degrees Kelvin. So what is the phase of matter of lithium? I'll do one more example at STP. STP is 273 Kelvin. That's the temperature that we're looking for. So if we're looking at lithium, which is right here, atomic number 3, 273 falls lower than 454. Therefore, it would be a solid. Physical properties are characteristics that don't change the substance. We have no new substance. For example, density, crushing, solubility, conductivity, melting point, boiling point, and phase changes. These are all physical properties and changes. Some signs of a physical property or change: it's still the same substance but in a different form or state of matter, solid, liquid to a gas. These are the key words to look for. It dissolves, it melts or boils, it is a solid or a liquid or a gas. A chemical property or a change is a characteristic that changes the substance. So a new substance is made. For example, reactivity, flammability, corrosive, decomposition. Some signs of a chemical and property change: a new substance is made that has different properties than its elements. For example, bubbling indicates a gas is forming. Words to look for: it reacts with water, it combusts, it corrodes. These are all words to indicate a chemical property or a chemical change. So try identifying the type of change. So to check your work, rusting iron is a chemical change, dissolving in water is a physical change, burning a log is a chemical change, and crushing a compound is a physical change. So check your understanding. So these lessons, this video's objectives: I can identify the states of matter, I can differentiate between physical and chemical changes, I can determine the phase of a substance at STP using table S, and I can construct particle diagrams for solids, liquids, and gases.